I can see that 8 to the power of 1 over 3 is looking like the fractional index of case 1 that I have it that I have recall. We can have this recall that a to the power of 1 over n is equal to the nth root of a. That means when you have a value, this is case 1, when you have a value raised to the power of a fraction, the denominator of the fraction becomes the root value. That's why having that nth root value of that number that was given to you. Then the numerator, since our numerator is equal to 1, just once you get the root value, you are good to go. Because even if you say all to the power of 1, it still becomes that value. Okay, having done that, let's work now. So I can, using that law, I can have it that this will now become cube root of 8 times 5 to the power of 2 over 3, all divided by 10 to the power of 2 over 3. Now, cube root of 8 is equal to 2, because when you have 2 times 2 times 2, it will give me 8. It simply means what value is going to multiply itself 3 times to get 8. That is the cube root there. Okay, times. Now, the cube root of 5 is going to be difficult because it is not going to be a whole number. I'll just have to write it down. 5 to the power of 2 over 3 over. Likewise here, I have to. Now, likewise here, the same thing is applicable, but I'm going to do something here now. Just watch and see what I'm going to do. Now, 10 is still the same thing as having 2 times 5, all to the power of 2 over 3, because 2 times 5 is still equal to 10, right? I can rewrite this to be 2 to the power of 4, because 2 is still the same thing as 2 to the power of 1 times 5 to the power of 2 over 3, all divided by, now this power is for both 2 and for both 5, so I have it to be 2 to the power of 2 over 3 times 5 to the power of 2 over 3. Okay, I haven't gotten to this, but you can see that this and this are having the same base, this and this are having the same base. As you are working, gradually everything is unfolding. Now, so I can quote the division law here because I'm dividing powers of the same base. And you see, when you're dividing powers of the same base, you take one of the base, then you subtract the power. So you start from the numerator power, 1 minus 2 over 3 times. Now you come to this, the same thing is applicable here because they have the same base and you are going to divide. So when you're dividing powers of the same base, you still do what? Take one of the base, you subtract the powers as well. 2 over 3 minus 2 over 3. So long as they are the same base, you just pick one, then you subtract their powers because you are dividing. Now here, I'll just put over 1 here and find the LCM. I'm going to have it as 2 to the power of, the LCM of 3 and 1 is still 3 over 3 divided by 1 is 3, 3 times 1 is 3, minus 3 divided by 3 is 1, 1 times 2 is 2, times, now you come here. Now this and this are the same, so 2 over 3 minus 2 over 3 is equal to 0, so I'm having it to be 5 to the power of 0. And here I'm going to have 3 minus 2 is 1, so I'm having here to be what? 2 to the power of 1 over 3 times. Now here has led us to 0 index, which says that when you have any value to the power of 0, it becomes 1. So 5 to the power of 0 is 1. And 1 times any value is still that value. So our answer is going to be 2 whole number 1 over 3. Alright, thank you guys for watching.